Why is it important to have well-structured soil? A well-structured soil will allow water to gradually flow through it. As the water passes down through the soil profile, it creates a vacuum, and so fresh air is drawn into the soil, thus creating aerobic or oxygen-rich conditions. This is crucially important, as the majority of disease-causing microbes cannot operate in oxygen-rich environments, and they are forced to shut down. Meanwhile, beneficial microorganisms thrive in oxygen-rich environments. Water droplets are held in the numerous cracks and crevices, and in organic matter for long periods of time, thus increasing drought resistance. Good structure allows plant roots to move effortlessly through the soil profile without having to work hard against compaction layers. In soils where good structure has not been built by beneficial microorganisms, compaction layers are easily formed by vehicles, by human and animal traffic, and where the soil surface is left bare by rainfall. Compaction layers force plant roots to grow sideways, limiting their access to nutrients and water. When plant roots break through compaction layers, they encounter anaerobic or low oxygen conditions. Those are occupied by anaerobic microorganisms, which produce highly acidic compounds. Roots cannot survive in such conditions where the pH can be lower than 4. When water flowing through a soil meets a compaction layer, it can't get through, and so, in heavy rain, this can result in a saturated layer of soil sitting on a hard compaction layer. If there is an incline, the topsoil can start to move, resulting in a landslide. This type of soil erosion is a big problem in many places around the world. So how is good structure built by the soil food web? Well, this depends on the type of soil we're dealing with. The terms sand, silt, and clay describe the size of the soil mineral particles. Sand particles are relatively big, and so are the spaces in between them. Water quickly finds its way through the gaps, and not very much water is retained, especially if the organic matter content is very low, as organic matter can absorb huge amounts of water. So sandy soils tend to be very dry and are prone to wind erosion, which is the process by which the topsoil is blown away and lost. Soil erosion is a serious environmental problem and poses an existential threat to humanity, as we only have around 60 years of topsoil left in the world, according to recent estimates. With the soil food web in place, the picture rapidly changes. Beneficial bacteria produce sticky compounds, or glues, which make it easy for them to adhere to the surfaces of organic matter and sand particles. These particles then adhere to one another, forming microaggregates. Notice how as things clump together, small spaces are created around them. Fungi also produce some glues, and their long, narrow tube-like structures act like ropes, tying together the microaggregates to form macroaggregates. Now even larger spaces are formed in the soil structure. When microarthropods, earthworms, and insects burrow through the soil, they create even larger spaces like tunnels. All the while, the soil food web is increasing soil organic matter in the soil profile by decomposing the surface litter into humus and transporting it deeper and deeper into the soil. Soon you can dig down and discover layer after layer of dark chocolate brown soil where there was once only lightly colored sand. The result is a structure that will hold water for several months after the rains have stopped, making it available to plants in times of drought. Roots are able to dig much deeper and to access more water and nutrients in parts of the soil that were never available to them before. In essence, the subsoil has now become topsoil. Dr. Ingham and her team have worked on landscapes such as pastures, turfed lawns, and golf courses, where the grass roots were only able to grow an inch or so into the soil because of the presence of compaction layers. In just a few short months after the soil food web is restored, those same roots are able to grow more than 3 feet deep, accessing more water and nutrients than ever before. In clay soils, the problems are a little different. Clay particles are often referred to as platelets, as they are kinda round and flat like the plates you have in your kitchen. Without a balanced soil food web, these platelets get stacked up on top of each other, forming very tightly compacted structures. Compaction layers can form very easily in clay soils. The solution to this problem is finding a way to get those clay particles to stop stacking. This can be achieved by a process called flocculation. Flocculation occurs when sufficient positively charged calcium ions are present on the surface of the platelets. This results in them repelling each other just like magnets do when their poles are aligned. The soil food web increases flocculation, and once this is achieved, structure can be built in just the same way as with sand particles. The result, once again, is a well-structured soil that enables plants to access more water and nutrients than ever before. For farmers, this means increased yields. cost savings due to reduced irrigation requirements, and even further cost savings as there is no longer any need to plow. Lower costs and increased yields result in greater profits. For the environment, there are a number of benefits. A well-structured soil that is home to the soil food web purifies water as it passes through the soil profile. This is because any contaminants in the water are seen by bacteria and fungi as nutrients, and are rapidly absorbed into their bodies as the water passes by. Soil erosion by wind and water are greatly mitigated, offering food security to future generations. And finally, water vapor is one of the most abundant greenhouse gases. By enabling more water to infiltrate the world's soils and to flow into aquifers, we may be able to contribute to the fight against climate change. For more information about the numerous benefits of the soil food web and how you can get involved, visit soilfoodweb.com.